Right, from the earlier discussion, we have realized that actually the equation of a plane has three forms. The first form that you have learned and have a lot of practice on, the first form that you have already learned before is called the parametric form. I mean, mistake here. Just that I mean mistake here. So I need a plus mu. Okay, right. So these are the three forms. These are the three equations of the three planes. And as you already know, there are altogether three forms of equation of a plane. The form that you are already familiar with examples that we have done previously, this form is called the parametric form. So you have pi 1 in the parametric form, pi 2 in the parametric form, and pi 3 in the parametric form. So in this exercise here on page 118, we want to make an attempt to convert these equations into their other two forms. What are the other two forms? One of them is called the dot product form, and the third one is called the Cartesian form. So let's do the dot product form first. Now in the dot product form, the form of the equation of a plane look like this. R dot n equals to a number. In our notes, I'll just be considering our notes. In our notes, we call this number small p. Right? We call this number small p in our notes. Right? Some books don't use the letter p for this side. Some books might actually use d. It really doesn't matter. Like it's actually the same, just a number. It's just a numeral, a number. Right? And whether you know it as p or as d, it really doesn't matter. It's just a number. Right, so now we are going to learn how we can convert this equation into this form. So to convert into a dot product form, you always go through two steps. First step, okay? You want to find the vector n. How do you find the vector n? To find the vector n represents a vector that is perpendicular to the plane. So if this is the plane, right? The vector n is a vector that is like this, perpendicular to the plane. Right? So how do you find a vector that is perpendicular to the plane? The obvious choice is to use a cross product. How do we do it? Bear in mind that this vector, right, is parallel to the plane, and this other vector is also parallel to the plane, and they make very good choices that you can use. Now, if these two vectors are parallel to the plane, which I have drawn them like this, then you realize that the cross product of these two vectors will give you a third vector that is perpendicular to these two, and therefore it will be perpendicular to the plane. What I meant is this: if you have a plane, right? If you have a plane, okay, plane like this, right? A plane. You have one vector that is parallel to the plane, and another vector that's parallel to the plane. If you cross product these two vectors, you get a third vector that is standing upright like this. Can you see? And this third vector, which is the cross product of this and this, will give you a vector that is perpendicular to the plane. So this makes it easy for us by using cross product to find this vector simply by taking this cross with this. So let's practice our cross product again. How do you perform a cross product? By now you're expert. Cover the first row, and what do you have? You calculate the determinant, which is 1 times 1 minus this times this. It will give you a minus 3. And then if you cover the second row, it will give you a minus 6. And cover the third row, it will give you a minus 9. So there we are, a vector n which is perpendicular to the vector here, and the vector here, and therefore it will be perpendicular to the plane. So we have actually achieved our first objective of finding the vector n. Typically, when you conduct a cross product like this, if you get a big number, that's not really very big, but if you get a number that is potentially possible to be reduced, then chances are that people would, that instead of using this vector, they might choose to use n as equals to, don't blink your eyes, you could choose to take your n as 1, 2, 3. Why is it possible? This vector, if you cross product them, if you have a vector that goes up this way, this vector, which is opposite direction to this one, is just going downward, but it is still perpendicular to this plane. Not only does this thing go downwards, it's also actually shorter in that sense, right? Shorter than this. Like this vector actually goes the other direction, is shorter, and it's also possible to be used as my vector n here. Okay. Nevertheless, keeping to this original -3, -6, -9, I now want to conduct my second step. What's my second step? In my second step, I have to find the number p. Or I told you sometimes they use the letter d. How do you find this number? This number is found by doing this. P is equals to, you take a point on the plane, dot with the vector n. So in this case, a point on the plane, a good choice will be this vector. This is really a point on the plane. Remember, this represents a point on the plane. So I take this point, I dot product with this. What do I have? You're going to get -3, -30, and -45. So it's -78. This gives you a value of -78. Alright. So once you have the vector n and the number p, you can put it down, and there you are, the equation of the plane, -3, -6, -9 equals to -78. On the other hand, if you have actually used the other vector n and you do the same thing, okay, if you have chosen to use this green n, let's see what happens, okay? Then my value p will be equals to, how to find my value p? You take the point on the plane, the dot product with n, what do you have? You got 1 plus 10 plus 15. So you get 26. So if you have used this green color n, then your equation of the plane would look like this. 1, 2, 3. Lo and behold, they look different. However, very soon you'll find that actually these two are the same. If you realize that if I divide by -3 on both sides, I'll get this and this respectively. Try dividing by -3 to all of them and divide -3 on the right as well, you get this. So I want to assure that actually you could have a choice to keep to this or reduce it. If you keep to this, you get an equation which is the same as what you would have gotten had you used a smaller, so-called smaller n. Right? They are equivalent. So this is how you can actually find the equation of the same plane in a different form, and this form is called the dot product form. Right? So why is it dot product? For obvious reason, it's called r dot n equals the number. There's a dot product here. Right? So I have found my equation of plane pi 1 in dot product form. Then there's a third form of the equation of the plane that you need to find. So if I already have the equation of the plane in the dot product form, I now want to convert into the Cartesian form. Okay, to convert this into the Cartesian form. This is somewhat quite easy. Okay, how do you convert this into the Cartesian form? So based on this, right? Based on this, you just replace your vector r as x, y, and z, and you perform that dot product. You're going to get this answer of x plus 2y plus 3z equals to 26. And this is how you can easily convert from the second form into the third form. Where are the three forms? Maybe I should draw a demarcation. Okay, this is the parametric form. This is the dot product form. And then this third one is the Cartesian form. Okay, so now let us try to convert the second plane and the third plane also into firstly the dot product form, followed by the Cartesian form. So to convert this into the dot product form is r dot. Okay, so what you do is you want to cross product these two vectors. Okay, to get the vector n, right? First step is to cross product these two vectors. So how to cross product these two vectors? Cover the first row, and then do your determinants calculation. Cover second row. This gives you cover the third row. You get this. This is actually the cross product of these two vectors. Okay, let me just be sure that my calculation is correct. Okay, did I make a mistake? Oh, I think I did. Okay. Sorry, when you cover the first, yeah, this is -1. I made a mistake. Okay, this is -1. Yeah. Cover the first row. This times this minus this times this, so it's -1. Okay, then it's equals to find this number, right? To find this number, you just take this vector dot product with this. What do you get? You get actually 7. Check. Okay. So you can either write your equation of second plane like this, or you could even write it as this other one. They are equivalent. And then for the third type of equation, so based on this, right? Based on this, the third equation will be x plus 2y plus 3z equals to -7. Likewise, I can find the equation of third plane. Okay. Again, I want to cross product these two vectors. Color the first row. What do you have? Okay, -3 plus 4, so it's a 1. Cover the second one. Is 2. Cover the third one. Okay. Let me see. -3 plus 4 is 1. 0 minus 2. Okay. That one. Okay. That one is going to be 3. And then find this number. You take this vector dot product with this. You have 2 plus 4, 6 minus 6 is 0. And likewise, to write down the equation in the Cartesian form is x plus 2y plus 3z equals to 0. So now what we have done is we have actually managed to find the equation of the three planes pi 1, 2 and 3 in all the three forms.